Today we're going to continue looking at exponential growth and decay word problems. We were introduced to them during the last lesson, and today we're really going to solidify our understanding. So let's look at number one together. Number one says Perry invested $1,000 in an account with a 1.3% annual interest rate. He made no deposits or withdrawals on the account for 2 years. If interest was compounded annually, which equation represents the balance in the account after the 2 years? All right, so let's pull out the important pieces. First, he's starting with $1,000. So $1,000 goes out in front. Next, we always write parenthesis 1, and then we decide if this word problem signifies adding or subtracting. Is this account growing or decaying? Well, it's a savings account, so it is growing over time. We're going to use a plus sign. Next, we take a look at our percentage, 1.3%. We need to take that percent and divide it by 100. 1.3 divided by 100 is 0.013. So that's what we're going to write next. And then we close our parentheses and we put the amount of time in the corner. The amount of time is 2 years. So looking at choice A, B, C, or D, you can see that the correct answer is choice B. Let's look at number 2. Miami was given $3,000 when she turned 2 years old. Her parents invested it at a 2% interest rate compounded annually. No deposits or withdrawals were made. Which expression can be used to determine how much money Miami had in the account when she turned 18? Okay, so the first important piece to this is the $3,000 that she's starting with. That goes out in front. Then we always do parenthesis 1, and we decide if this account is growing or decaying. This account is growing. They invested money in a savings account. So we're going to use a plus sign. Next, we need to take 2% and divide it by 100 to turn it into a decimal. 2 divided by 100 is 0.02. Close the parentheses. Now, we need to put the amount of time in the corner. The amount of time for this problem is a little confusing. It told us that she was given the account when she turned 2 years old. And they want to know how much money would be in the account when she turns 18 years old. So how much time is that? If she got it when she was 2, and they want to know how much is in there when she turns 18. How many years is that? Well, 18 minus 2 is a difference of 16 years. That's how much time we're talking about in this problem. From age 2 to age 18 is a matter of 16 years. So, looking at choice A, B, C, or D, we can see that the answer is choice A. That's a tricky one. All right, in numbers 3 and 4, the focus is on the percent change. So they actually give us the equation in the problem, and they want to know about the percent change. Let's read what it says. The equation A equals 1,300 times 1.02 to the 7th power is being used to calculate the amount of money in a savings account. What does 1.02 represent in this equation? Here's what I want you to do. I want you to rewrite this equation expanded. So if we rewrote this equation expanded, we'd have a 1 and then a plus sign, and then a 0.02, then a parenthesis and a 7, right? If we expanded that inside part, 1.02, it would be expanded to say 1 plus 0.02. So what is 0.02 as a percentage? We're actually going backwards from what we normally do. So instead of taking 0.02 and dividing by 100, I'm going to take 0.02 and I'm going to multiply by 100 to find the percent change. 0.02 as a decimal is the same as 2% as a percentage. So we can knock out choice A and B. The percent change is not 0.02%, it's 2%. Is it growth or is it decay? Well, we were using a plus sign, right? This number was bigger than 1. So it's 2% growth. Let's look at number 4, similar type of problem. Number 4 says the function v of t equals 1,350 times 1.017 to the t power represents the value v of t in dollars of a comic book t years after it's purchased. The yearly rate of appreciation, which means growth, of the comic book is what? So let's do the same thing for this problem. Let's break this parenthesis piece apart. So if we broke it apart, our function would look like this. V of t equals 1,350 times 1 plus 0.017 to the t power. 0.017. We need to change this decimal into a percent. So get your calculators and type 0.017, and instead of dividing by 100, we're going to multiply by 100. That is 1.7%. So the answer is choice B. Let's flip the page to page 19. Okay, we're actually going to skip number 5 because the last video went a little long and I don't want this one to be quite as long. So we're going to jump ahead to number 6 and 7. Samuna deposited $3,000 in an account at the Merrick National Bank, earning 4.2% interest compounded annually. He made no deposits or withdrawals. Write an equation that can be used to find B, his account balance after T years. So here's something I hope you heard. It said write an equation. It's not asking for a dollar amount. It wants us to just write the equation. The other thing it told us is to use the letter B to represent the total balance. So our equation is going to start with B equals, and then we're going to fill in all our pieces, starting with the $3,000. That goes out in front, parenthesis 1. We're talking about a savings account that is growing over time, so we're going to use a plus sign. Next, we need to take 4.2% and change that into a decimal. So 4.2 divided by 100 is 0.042. So that's what comes next in our equation. Then we have parentheses and our amount of time in the corner, which they just want us to use the letter T to represent time. So we're going to put a T in the corner. So this is an equation to represent this problem. We don't need to do anything further. In fact, we can't do anything further because there's no number up here. So we couldn't even type it into our calculator if we wanted to. Let's move on to number 7. Abdi invested $600 in a savings account at a 1.6% annual interest rate. He made no deposits or withdrawals on the account for 2 years. The interest was compounded annually. Find, to the nearest cent, the balance in the account after 2 years. So this time they actually want to know about the money. How much money is in the account after 2 years? All right, let's piece it together. We're starting with $600, parenthesis 1. We're talking about a savings account that grows over time, so we're going to use a plus sign. Next, we need to take 1.6% and change that into a decimal. So 1.6 divided by 100. Let's see what we get. We get 0.016. So that comes next. Close our parentheses, and then we put our time in the corner. Our time is 2 years. Now this we can type in because it's all numbers. And in fact, it wants us to type it in because they want to know how much money is in there after 2 years. So let's do it. 600 times 1 plus 0.016 parentheses to the second power. So after 2 years, there would be $619.35 in the account. Okay, last two. Number 8. The value in dollars V of x of a certain car after x years is represented by the equation V of x equals 25,000 times 0.86 to the x power. To the nearest dollar, how much more is the car worth after 2 years than after 3 years? So this is a different type of question than we've been asked before. It wants us to compare how much the car is worth after 2 years and after 3 years. 2 years and 3 years, that's talking about time. So what we need to do is in the corner here, where the x is, we need to sub in a 2 and see how much the car is worth then. And then we need to sub in a 3 and see how much the car is worth then. So let's start with 2 years. 25,000 times 0.86 to the second power, because we want to know how much the car is worth after 2 years. Let's type this into our calculators. It is worth $18,490. Okay, well now we need to know how much is the car worth after 3 years. So now we're going to take the same equation, but this time we're going to sub in 3 years where the time goes. So let's type this into our calculator and see how much the car is worth after 3 years. So we have 25,000 times 0.86 to the third power. So after 3 years, the car is worth $15,901.4 or 40 cents. So after 2 years, the car is worth $18,490. After 3 years, the car is worth $15,901. They want to know how much more is it worth after 2 years than it is after 3 years. So what we're going to do next is we're going to take those two numbers and subtract them. We're going to find the difference. 18,490 minus 15,901.4. And this is going to give us the difference in how much the car is worth. So 18,490 8,490 minus 15,901.4 is 2,588.6. So looking at the choices, what is this answer closest to? A, B, C, or D? It is definitely closest to choice A. The car is worth $2,589 more after 2 years than it is after 3 years. Number 9. For a recently released movie, the function y equals $119.67 times 0.61 to the x power, that models the revenue earned, y, in millions of dollars each week, x, for several weeks after its release. Based on this equation, how much more money in millions of dollars was earned in revenue for week 3 than for week 5? So again, we need to sub 3 in for the time, see what it was worth, and then sub 5 in for the time, see what that was worth. And then we need to take those answers and subtract them to find the difference. So let's start with week 3. We're going to take 119.67 times 0.61, and we're going to sub 3 in for the time. Let's see what we get. 119.67 times 0.61 to the third power. 27.16 if we round it. Okay, now we need to see how much revenue was made after week 5. So same equation, 119.67 times 0.61, but this time we're going to sub in 5 for the number of weeks. Let's see what we get now. Hmm, 10.11 if we're rounding. So what we need to do is take those two numbers, the amount of revenue it earned after 3 weeks, and subtract the amount of revenue it earned after 5 weeks to find the difference. Let's see what we get. 27.16 minus 10.11 . 17.05, meaning it earned 17.05 million more after the 3rd week than it did after the 5th week. And what answer is that closest to? A, B, C, or D? That is closest to choice C. So C is our answer. I know that was another very full lesson and a longer lesson. So thank you for hanging in there. We're going to review exponentials in the next lesson.